Hi everyone. So here's part two to the osmosis or osmotic rate calculations. So some of you guys are asked or sending me questions because you weren't sure how to calculate, uh, or, the final osmotic rate for each of the sucrose solutions. But this is what you're doing. So this is the sheet that I was sharing with you guys last time. So in that video, I already calculated the osmotic rates for each time interval. Right? And if you remember, the formula for each of these is you can, once you click on the actual value, it'll show you the formula that you applied. But if you want to figure out the osmotic rate across the 90-minute experiment, which is what it's asking for here, then it's the same formula. You're just making slight adjustments. So if I wanted to know the osmotic rate across the entire 90 minutes that the experiment took place in, I would just use the formula, the same formula. So again, this is the formula. So I would use the average normalized weight for the 90-minute mark. So equals, and I'm going to open my parentheses here, equals the final weight minus the initial weight, which is the zero one. Okay. And again, I'm working with the average normalized weights here, not the osmotic rates. And so minus that, I'll close the parentheses, and then I'll divide it by the time interval 2 minus 1. So in this case, if you're getting the osmotic rate across the entire 90-minute time period, then you would have to do 90 minutes minus 0. So here I'm dividing by 90. Okay? And that's going to be the osmotic rate for the, this is, in this case, I'm working with the distilled water. So this is the 0% sucrose, right? So you can do it that way. Another way you can do it is by averaging your osmotic rates that you already calculated. So let's say, because I could show you, it's going to be the similar number. So I put equals, and now let's see, get the formula for average equals the average of these osmotic rates. Okay, it's still giving me 0.08. So if I wanted to make sure that that's the right value, I'll increase the sig figs. But yeah, it looks similar. It's the same thing. So you can get it two different ways. You can either apply the formula again by subtracting your final normalized weight minus the initial, and then divide that by the 90 minutes, right? Because it's time one minus time two minus time one. Time two is the 90-minute mark. Time one would be the 0 mark. So it would be 90 minus 0 is 90. Or you can just average out the osmotic rates starting with the 10 mark, and you'll get the same answer. Okay. So once you have your osmotic rates for each one, so you have one for the one that I just generated was for the 0%, the distilled water. But you're gonna have to do the same thing for the 10%, 20, 30, and 40. And you'll do the same for the unknowns. And then once you do that, you'll be able to graph your values. You just have to make sure that your independent values, so the ones that are going on the x-axis, are going to be the solute concentrations. So here you should have something that looks like 0%, 10%, 20, 30, and 40%, because those are your independent variables. On the y-axis, you're going to have your dependent variables. So in this case, this is where you're going to mark your osmotic rates. So you'll have a different scale here, but it will be for the osmotic rates. Then all you're doing is you can do it either way. You can either if you want to do bars, you can do bars. If you want to do a scatter plot, you can do a scatter plot. But pretty much all you're doing is you're connecting, uh, you're essentially marking the place where the osmotic rate matches the um, solute concentration or the sucrose concentration. So again, in our example, for the distilled water, this is the osmotic rate across the entire 90-minute mark. It's 0.08. So if I were going to graph it, this would mark the distilled water, so 0% sucrose. 0.08, it would depend on how I make my scale here, but I would just mark the area where the zero point zero 0.08 matches the 0% sucrose. So, and that's pretty much what you have to do here. So hopefully this helps.